Okay, what I'm going to do here, oops, oh no, I broke it. Not ideal, right, okay. I'm just going to put a wee deadline here, and we're going to talk about bit. Now, much like pixel, bit is made up of two words stuck together. Do you know what they are? Again, quiz question stuff.
Binary.
Good, binary. Good guess. Binary digit. Right? A bit. What does a bit look like? It's just, yeah, it's very simple. It's a 0 or a 1. And that is it. There's no more to it than that. Now, the reason we use bits is because computers understand it in terms of storage. In its most basic form, it is on or off, it is black or white, it is 0 or 1, right? It's true or false, that's how the computers think. Now, if I was to write down 0, 0, 0, 1, what is that?
It's a byte.
It's a byte, excellent. That is a byte, okay. That makes up 1 byte. Now, if we were to think about megabytes, it's a megabyte's a million of those, right? But to make it a wee bit easier, that essentially would be a letter. So 1 byte equals 1 key press of a letter on a keyboard. So if you had a disk that could hold a megabyte, a million bytes, it could hold a million letters. Does that make sense? Does that give you some sort of quantifiable? So it becomes very hard because a million you can kind of imagine a million. What about a million? Can you imagine that in your head? It gets harder than a million. It becomes very difficult to imagine. For a wee bonus, Mark, and this is I'm not winding these up, right? I'm not kidding you on. What is that known as? If that's a byte, what's 4 bits known as?
It's a little like.
Say it.
Yeah, nibble.
It's a nibble.
Yeah.
Right, I'm looking at it. It's a nibble. 4 bits is a nibble. As in the wee nibble of it. Right? I'm not kidding you on, but that will come up in the exam, but I think it's pretty funny. So, in terms of how we're storing things, if something is 250,000 bytes, so that'd be 250 kilobytes, that's the equivalent of 250,000 key presses. If that gives you some sort of idea of how much data that would be.
How does that relate to bit then?
A bit. So there's 8 bits in 1 byte. Right? So that's why, what number system are you comfortable working in? What was the easiest times table to learn apart from 1? 10. Agreed? Dead easy 10 times table. Right? I'm not going to make you do it. But why do we count in tens? Why is that easy for us?
Just adding zeros then. 10 digits.
We've got 10 digits. Computers don't have 10 digits. Computers think in zeros and ones. So, see all these numbers we've been talking about, they're a bit weird, aren't they, today? That's better. So, if we earlier on we were talking about 16.7 million colours, 256 colours. Does anyone, I've used American spelling, sorry. Does anyone think that that's just a strange number? Yeah. It's a bit kind of out there, isn't it?
It's when we have it done written to 256 of it.
Right, so I'll explain this, right? Again, please understand, this is just to back up your knowledge. There's no questions in the exam on this, right? I just wanted to talk to you about why we're talking about file sizes. 256 colours, right? And it is weird. Say we've got a wee box, right? And we're only using binary. How many different values can we store in that wee box?
2.
We can store 2 values, right? Not at the same time, but there's 2 options, okay? We could put a 1 in there, absolutely fine, agreed. Or we can put a 0 in there. Right, so there's 2 combinations. If we have 2 boxes, how many combinations can we have?
4.
Right, talk me through them.
0,
0, 0,
1,
1,
1,
1,
1, 0, 1,
1, 0, 0, 1. 4? The penny's dropped. Right, we won't do this forever, right?
We should get to 256.
So I've got 3. How many?
Oh, fuck.
We'll try it and see. We won't go beyond 3, don't worry.
16.
Now let's give that a go. Alright, let's try and do a logic here. You help me. So I've got 0, 0, 0.
0, 0, 1. 0, 1, 0. 1, 0, 0. 0, 1, 1.
Could be under
1, 1, 1.
1, 0.
1, 1, 1.
I can't even see. 1, 1, 1.
0, 0, 0. 1, 1, 1. 1, 1, 1.
0, 0, 0.
0, 0, 0, yeah.
1, 2, 3, 4, 5, 6, 7. Any more?
Oh, I don't know.
Right.
Let's just
No.
squeeze probably.
There's not any more. Right, well done.
2, 5, 6 is the maximum.
Now, will I talk to you and we do one more? Or will we stop at that point and I'll tell you how you do it?
That's not the another.
I'm a visual learner, so I think we might have to go all the way up to 2.
So, as you can imagine, it,
Next one, 32. 16.
right,
Is it?
Yes, it's
16, 32, 64, 42.
it's the
16,
number.
32, 64, 128.
yes, got it, right, okay. So, see if we think about, again, I'm just going to mention maths a wee bit here then, what? So, if we've got 2, what is 2 to the power 1? What's the answer?
2.
What's 2 to the 2? What's 2 squared?
4.
What's 2 to the power 3?
8.
2, 4, 8. We've got 1 gap there, we've got 2 there, we've got 3 there. So you put it to the power. So 2 to the power 4 is equals 16. 2 to the 5 equals 32.
64.
2 to the 6 equals 64.
128.
2 to the 7 equals 128. And lastly, 2 to the power 8, which is 8 bits, is 256. That's why we get these weird numbers, right? Does that make sense to you? So if I was to get the 8 boxes and ask you to fill them all in, there would be a possible 256 combinations, and we'd be here a wee while double checking it. But luckily we can just put it to the power, and we know that. Right, now you might need a calculator for this. So if, see, I'll jump out a few. What's 2 to the power 16? Use your calculator if you want. Or just go like that.
16.7 million. I'm just gonna throw that guess in there.
Is that 12, 16, 17?
Don't work out, if you work out in your head, you're in the wrong place if you do this in your head.
6,536. 65,000.
65,000.
536.
Okay. What about 2 to the 64?
That would be the 760.
Should we countdown music on?
You, Carol.
It's done the E19
Oh,
thing,
right.
so I'm not.
Okay, so listen, right, okay, try 32. Try 32 for me. And let's see if it does that.
4,294,967,296.
Right, I'm not writing that down. Right, so, but the more, and essentially see when we think about these, the more spaces we've got, the more stuff we can store. That's how computer storage works. Right, so the more spaces we've got to put in data, the more information we can represent. What time is it? I'll do one more wee thing, again, not examined on, but just to explain to you. I'll do a wee joke to finish off with.
Okay.
It's not a good joke. Right. There are 10 types of people in the world who understand. I can see you all falling out laughing at that joke. Does it make sense?
Yeah.
What is the joke?
Fertility's
1, 0.
Right, so if you read that normally, what does it say?
It's 10 types of people, but actually it's binary for 1 and 0.
Which is?
2.
Yeah, right. So the joke here is there are 2 types of people in the world that understand binary, right? Because that written in binary is 2.
You have to say, does it make sense at the end of the joke?
Right, so so the joke here is it's a totally different number system. There's hexadecimal number systems as well, right? Which we will actually touch on again because we need to look at colours at some point. But if we write down if I write that down, what number is that? It's 2, right? The zeros are zeros, they're actually worthless, but I'm just putting it down so it's in the sign of a byte. So in there, in the number system, that represents a 1, that is a 2, that is a 4, 8, 16, 32,
64.
64, and 1, 2, 8. Okay? And what you do is you go along here, you might have seen this before, you go along here and just add up the columns. So 0, 2, 0, 0, 0. So it's 2. So that means 1, 0 in binary is 2, which makes the joke hilarious. Yeah? Right, so that is the number 2 in binary, in the binary number system. If we were to fill them all in with ones, what number do we get?
256.
We get 256. So you can represent 256 values. Because if we say 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 is 256. What is it?
Sometimes 128, because when they were limited to 8-bit, if they wanted to do negative numbers, that would switch over, so you couldn't use it.
So I'm going to ask you to do one more wee sum for me before we finish. Can you, if you've got a calculator, phone calculator, whatever, add
Yeah, that doesn't look right.
all those numbers up for me?
They're all even.
Right, go, do it for me, do it for me. Go on, go on.
To waste mine.
Is what I've written on the board correct?
In computer logic it is, in human logic it's not.
Isn't it zeros?
Is it zero based?
It's
Is it
255.
Right, we're missing a number.
zero based? Zero counts as a number.
Yeah, right, so that's actually 255. Now, the reason it has to be 255 is there's only one odd number there, and we're using it, so that makes it odd, right? Oops. So that is 255. The trick here, though, is that it can hold 256 values. Because it starts at 0 and goes to 255. 0 is the first value, 255 is the 256th value. Right? So if I was to ask you to count to 10, go.
No.
Right, so read it, you all start at 1. Yeah, fuck you. Right, you all start at 1. We as humans aren't conditioned to count 0. Right? Whereas the computer does count 0. So that's why it can hold 256 values, but it only goes up to 255. You probably, if you've done programming loops, you'll have seen this, and it's so annoying, but you get used to it. Okay? Right, so see all that stuff under the red line? You can go out of here and forget all about it forever. Right? That's not important. The stuff here that I put in yellow is important, and it will get you the marks in the exam. So, the aim of today, we're nearly there. It was really just to come in and meet you, to get you, to get used to me, to get used to you, and start prepping for the exam. So, what I'll do with that stuff I've recorded, I'll probably stick it onto, I'll try and put it together and put it on YouTube, and then put a link to it on Canvas, so it's there for you. And we'll probably try and use that each week and see how it goes. If you get any suggestions, if there's something you want to cover, if you think there's something we can do better, tell me. Alright? Like and subscribe. It's funny because most of the stuff I just put as unlisted. There's a couple I forgot to. And there's one I got loads of it hits on. It was doing some sort of installation in Linux, right? Something obscure, and it's people like, what language are you speaking? English. So, the Scottish accent doesn't travel well. So, right, listen. I hope that was alright for you, and I hope you aren't feeling too worried about the exam. By the time I'm done with you, you'll be more ready.
Thanks.
Alrighty.
Yeah.
Right, are you using this afternoon?
Yeah.
Who you got?
Yeah.
Yeah, we'll be fine. What you got? What subject?
The big one.
Team Morton. Right, go. Aye. You seem a personable bunch. I'm sure you'll be fine. Morton and a team. Right, I'll shut up. Have a nice break, and I will see you next week. Okay.